Hello and welcome to this video. In this video, we are going to solve some of the integration question from the past paper. To solve these questions, we are going to use these key points. The first question is, the diagram shows the curves with equation y is equal to 2 times 2x minus 3 the whole power 4 and y is equal to 2x minus 3 the whole square plus 1, meeting at points A and B. By using the substitution y is equal to 2x minus 3, find by calculation the coordinates of A and B. So two curves are given. We need to find the meeting points. So point of intersection. That means we can write y is equal to 2 times 2x minus 3 the whole power 4, which is equal to 2x minus 3 the whole square plus 1. That is, we are equating the equation of the curves. Okay, and it's given we need to use 2x minus 3 as u as a substitution. The first equation will become y is equal to 2 multiplied by u power 4. And the next equation will become y is equal to u square plus 1. Now let's equate both the y values. So we get 2 u power 4 equal to u square plus 1. So now bring all the term into one side. So we get 2u power 4 minus u square minus 1 is equal to 0. Let's solve this equation. For that, let's take a is equal to u square. So we get 2u square minus 2a square minus a minus 1 equal to 0. Now we need to factorize this one. So how to factorize this one? Write the coefficient of b, which is negative 1, and a multiplied by c, which is negative 2. Okay, so when you multiply 1 by 2, we get 2, but we need to get negative 2. So I'll put a negative sign here. When you add 1 and negative 2, we will get this negative 1. Okay, so this can be written as 2a square. This minus a can be written as minus 2a plus 1. Okay, let's write negative 1 equal to 0. So this is 1 and negative 2. So for this, I have written negative 2a and positive a. Okay, now take 2a commonly. We get a minus 1 plus 1 times a minus 1 equal to 0. So 2a, if you take a minus 1 commonly, you get 2a plus 1 equal to 0. So the a value is 1 and 2a plus 1 equal to 0. So when 1 goes to other side, it will become negative 1. So a will become negative 1 over 2. Okay. So let's write this is u square equal to 1 and u square equal to negative 1 over 2. So what is the u value is equal to plus or minus 1. and here u will be square root of negative 1 over 2, which will not give any solution in this case. So let's leave that. So we'll take u is equal to plus or minus 1. Okay. So when u is equal to plus 1, let's substitute u is equal to 2x minus 3 to find the value of x. 1 is equal to 2x minus 3, or we can write 2x equal to 1 plus 3. So x equal to 4 divided by 2, which is equal to 2. Okay. So when x equal to 2, what is the corresponding y value? Is equal to, let's substitute in this. You can substitute any one equation. 2 multiplied by x, which is 2, minus 3 the whole square plus 1. So 4 minus 3 is 1. 1 square plus 1 is 2. Okay. So this point is 2, 2. When u is equal to negative 1, negative 1 equal to 2x minus 3. So what is 2x? 2x equal to 3 minus 1, which is 2. So x equal to 2 divided by 2, which is 1. Okay. So what is y value? Y is equal to 2 times 1 minus 3 the whole square plus 1. 2 times 1 is 2 minus 3. So you will get negative 1. Negative 1 the whole square is positive 1. With that add 1, you get 2. So this is 1, 2. So we got 1, 2 and 2, 2. So A will be 1, 2 and B will be 2, 2, because this 1 and 2 are the x coordinate value. So A will come first. So we will take A as 1, 2 and B as 2, 2. The next part of the question is find the exact area of the shaded region. So now we know A value as 1, 2 and this is 2, 2. So the corresponding x coordinate value will be 1 and here it will be 2. Okay. So we have to take the limit as 1 to 2. And this is the upper curve. So area under the upper curve minus area under the lower curve will give the shaded region. Area under the shaded region. So area is equal to integral 1 to 2. The upper curve is 2x minus 3 the whole square plus 1. Okay. From that you subtract the lower curve, which is 2 times 2x minus 3 the whole power 4. times dx. Now let's integrate this one. 2x minus 3 the whole cube, whole square will become whole cube. 2x minus 3 the whole cube divided by the power, which is 3, multiplied by the coefficient of x, which is 2, plus the constant on integration gives x, minus 2 times 2x minus 3, increase the power by 1, so 5, divided by the power 5, multiplied by the coefficient of x, which is 2, and the limit is 1 to 2. Okay, we can cancel these two 2's. First, let's substitute the upper limit 2. So this will be 1 over 6 times 2 times 2 minus 3 the whole cube plus 2 minus 1 over 5 times 2 times 2 minus 3 the whole power 5. Then let's substitute the lower limit, minus 2 times 1 minus 3 the whole cube divided by 6 minus 1, then minus into minus, it will become plus 1 over 5 times 2 times 1 minus 3 the whole power 5. So 1 over 6, 2 times 2 is 4, 4 minus 3 is 1, 1 cube is 1. So plus 2 minus 1 over 5 multiplied by, this will also be 1, 1 power 5 is 1, minus 2 times negative 3. So you will get negative 1. Negative 1 over 3 will give negative 1. So this will become positive 1 over 6. Negative 1. And here 1 over 5 times negative 1 power 5, which is negative 1. So negative 1 over 5. So let's combine 1 over 6 terms. We have 1 over 6 here and here. So 2 times 1 over 6 is 2 over 6 plus 2 minus 1 is 1, and combine this negative 5 term. So we get negative 2 over 5, and this can be simplified as 1 over 3 equal to, let's take LCM, 15. So 5 times plus 15 minus 6. This is equal to 20 minus 6, which is 14 over 15. So the area of the shaded region is 14 over 15. Next, question number 2. A curve has a stationary point at 2, negative 10 and is such that d square y by dx square equal to 6x. Find the equation of the curve. D square y by dx square is given. So first let's integrate this one so that we will get dy by dx. Then again integrate that one to get the equation as y is equal to the equation. Okay. So first let us find out what is dy by dx is. So dy by dx is, integrate the given function 6x dx. So on integrating we get 6x square divided by 2 plus c. Okay. So it's given the curve has a stationary point at 2 comma negative 10, that is dy by dx is 0 at 2 comma negative 10. So at 2 comma negative 10, dy by dx is 0. So 0 is equal to, we can simplify this as 3. 3 times, substitute the x value as 2 square plus c. So the c value is 3 times 4. When it goes to other side, it will become negative 12. So dy by dx is 3x square minus 12. Now to get the equation of the curve, again integrate this one. So we get y equal to integral 3x square minus 12 times dx 3x cube divided by 3 minus 12x plus, instead of c, I will use the constant k here. Okay, so let's cancel these two. To find the constant value k, let's substitute the point 2 comma negative 10. Y is negative 10. 2 cube minus 12 times 2 plus k. So k is equal to negative 10. 2 cube is 8. So negative 8 plus 12 times 2 is 24. So this is equal to 6. So the equation of the curve is y is equal to x cube minus 12x plus 6. The next question is, the equation of the curve is such that dy by dx equal to 1 over 2x plus 72 divided by x power 4. The curve passes through the point 2 comma 8. Find the equation of the curve. So this is similar to the previous question. We need to integrate this one to get the equation of the curve. So y is equal to integral 1 over 2x plus 72. I'll bring this x power 4 in the denominator to the numerator, so the power will become x power negative 4 dx equal to 1 over 2 x square by 2 plus 72 x power negative 4 plus 1 will become negative 3 divided by negative 3 plus the constant c. So this is equal to x squared by 4 minus 24 times x power negative 3 can be written as x power 3 in the denominator plus c. Okay, to find the value of the constant c, substitute the point 2 comma 8. So y is 8, x is 2, so 2 square divided by 4 minus 24 divided by 2 cube plus c. So c is equal to 8. These two gets cancelled and this is 24 divided by 8. So this is 3. So 8 minus 1 plus 3, which is equal to 10. So the equation of the curve is y is equal to x squared divided by 4 minus 24 divided by x cube plus 10. The next question is, the diagram shows curves with equation y is equal to 2x power 1 over 2 plus 13x power negative 1 over 2 and y is equal to 3x power negative 1 over 2 plus 12. The curves intersect at the point A and B. Find the coordinates of A and B. So these two curves intersect at the point A and B. So to find the intersecting point, we need to equate both the equations. So 2x power 1 over 2 plus 13x power negative 1 over 2 is equal to 3x power negative 1 over 2 plus 12. Bring all the term into one side. So we get 2x power 1 over 2 plus 13x power negative 1 over 2 minus 3x power negative 1 over 2 minus 12 equal to 0. Let's simplify this one. So 2x power 1 over 2 plus 13 minus 3 will be 10. 10x power negative 1 over 2 minus 12 equal to 0. Divide all the term by 2 on both the sides. So we get x power 1 over 2 plus 5x power negative 1 over 2 minus 6 equal to 0. This can be written as x power 1 over 2 plus 5 over x power 1 over 2 minus 6 equal to 0. Now take the common denominator as x power 1 over 2. So this will become x plus 5 minus 6x power 1 over 2 divided by x power 1 over 2 equal to 0. Or we can write this as x minus 6x power 1 over 2 plus 5 is equal to 0. Okay, the denominator x power 1 over 2 goes to other side. So 0 multiplied by that term will become 0. Okay, to solve this equation, let's take t is equal to x power 1 over 2. So x will become t square. This will become negative 6t plus 5 equal to 0. Let's factorize this one. So t minus 1 multiplied by t minus 5 equal to 0. So t will be equal to 1 and 5. So x power 1 over 2 equal to 1 and x power 1 over 2 equal to 5. So square on both the side. So we get x equal to 1. And here if you square on both the side, you will get x equal to 5 square, which is 25. Okay. Then we need to find the corresponding y value. When x equal to 1, y is equal to, substitute in any one equation, 2x power 1 over 2. 2, 1 power 1 over 2 plus 13 x power negative 1 over 2, that is 1 power negative 1 over 2. This will be 2 multiplied by 1 plus 13 multiplied by 1, which is 15. So 1 comma 15. Okay. When x equal to 25, y is equal to 2 multiplied by 25 power 1 over 2 plus 13. I'll write x power 1 over 2 in the denominator as x power 1 over 2. So 25 power 1 over 2, which is equal to 2 times 5, which is 10, plus 13 divided by 5. So 50 plus 60, 13 is 63. 63 divided by 5. Which is equal to 1, 2, 3 over 5. Okay. So 25 comma 12, 3 over 5. So x value is 1 and 25. So this will be 1 and this will be 25. Okay. So this is 1 comma 15. Then this will be 25 comma 12 multiplied by 3 over 5. So this is A and this is B. Okay. Hence, find the area of the shaded region is the next part of the question. So to find the area of the shaded region, we need to take the limit value as 1 to 25 and the upper curve, area under the upper curve minus area under the lower curve. So area is equal to the limit 1 to 25. The upper curve is 3 x power negative 1 over 2 plus 12 minus 2x power 1 over 2 minus 13x power negative 1 over 2 times dx. Let's integrate this one. 3x power negative 1 over 2 plus 1 will be positive 1 over 2 divided by 1 over 2 plus 12x minus 2 multiplied by x power 1 over 2 plus 1 will be 3 over 2 divided by 3 over 2 minus 13 x power 1 over 2 divided by 1 over 2 and the limit is 1 to 25. Let's simplify this one. 6 x power 1 is already one more x power 1 is there. So okay, this will be 6 and that will be 26. So negative 20 x power 1 over 2 plus 12x minus 4 over 3 x power 3 over 2 and the limit is 1 to 25. Now let's apply the limit. Minus 20 times 25 power 1 over 2 plus 12 times 25 minus 4 over 3 times 25 power 3 over 2 minus into minus plus 20 1 power 1 over 2 minus 12 times 1 minus 4 over 3. This will become plus x power x is 1 power 3 over 2. So minus 20 times 25 power 1 over 2, that is 20 multiplied by 5 will be negative 100 plus 300 minus 4 over 3 times 25 power 3 over 2 will be 125 plus 20 minus 12 plus 4 over 3. Minus 100 plus 300 will be 200. 200 plus 20 is 220. Minus 12 will be 208. 208 minus 4 over 3 multiplied by 125 plus 4 over 3 will be 4 over 3 multiplied by 124. 208, 4 times 124 will be 496 divided by 3. Take LCM. 624 minus 496 divided by 3. So this is equal to 812 divided by 3. So 42 2 over 3. So area is equal to 42 2 over 3. Next, question number 5. A curve is such that its gradient at a point x comma y is given by dy by dx equal to x minus 3 multiplied by x power negative 1 over 2. It is given that the curve passes through the point 4 comma 1. Find the equation of the curve. Again, it is a finding the equation of the curve. So we need to integrate the given dy by dx function to get the equation y is equal to in the form. Okay, and to find the constant we need to use the value 4 comma y, which is the coordinated point given here. Okay, so first let's integrate the function, given function dy by dx. So y is equal to integral x minus 3 times x power negative 1 over 2 dx. This is equal to x can be integrated as x square divided by 2 minus 3 times x power, increase the power by 1. So negative 1 over 2 plus 1 will give positive 1 over 2 divided by 1 over 2 plus c. And it's given the curve passes through the point 4 comma 1. So this satisfies the equation. So y is 1, x is 4. 4 square over 2 minus 3 divided by half will give 6 multiplied by 4 power 1 over 2 plus c. Let's find the value of the constant c. C is equal to 1 minus 4 square divided by 2 will be 16 divided by 2, which is 8. So it will become minus 8 when it goes to other side. Okay, this is minus, so it will become plus 6 times 4 power 1 over 2. 4 power 1 over 2 is nothing but 2. So 6 multiplied by 2 will be 12. So C is equal to 5. Okay, so the equation of the curve is y is equal to x squared divided by 2 minus 6x power 1 over 2 plus 5. The next question is, the diagram shows part of the curve with the equation y is equal to x plus 2 divided by 2x minus 1 the whole square. The lines x equal to 1 and x equal to 2 intersect the curve at P and Q respectively, and R is the stationary point on the curve. Verify that the x coordinate of R is 3 over 2 and find the y coordinate of R. So we need to verify the x coordinate of R. And it's given R is the stationary point. So dy by dx is 0. Let's find out dy by dx. So first I'll write y as y is equal to x plus 2 times 2x minus 1 the whole power negative 2. Okay. Now differentiate this one. We get dy by dx is 1 plus 2 times negative 2 multiplied by 2x minus 1 the whole power negative 3 multiplied by the coefficient of x, which is 2. So 1 plus 2 times negative 2 times 2 will be negative 8 multiplied by 2x minus 1 the whole power negative 3. Okay. Or we can write this as 8 divided by 2x minus 1 the whole cube. Now we need to verify the x coordinate of R. So since this is a stationary point, dy by dx should be equal to 0. Okay. So if you substitute the x coordinate value as 3 over 2, it should be equal to 0. Let's check that one. Let's substitute x value as 3 over 2. So dy by dx is 1 minus 8 divided by 2 times 3 over 2 minus 1 the whole cube. So 2 and 2 gets cancelled. 3 minus 1 will be 2. 2 cube is 8. So 8 divided by 8 is 1. So 1 minus 1 is 0. Okay. Hence x coordinate of R is 3 over 2. Okay. We proved this one, this part. So we need to find the y coordinate of R. So when x equal to 3 over 2, what is the y value? Y is equal to x, which is 3 over 2 plus 2 divided by 2x minus 1 the whole square. So 2 and 2 gets cancelled. 3. So 3 over 2 plus 2 over 4, which is nothing but 3 over 2 plus 1 over 2. So 3 over 2 plus 1 over 2 will be 4 over 2, which is nothing but 2. So y value is 2. So R will be 3 over 2 comma 2. Okay. The next part of the question is find the exact value of the area of the shaded region. To find the area of the shaded region, we have to find first the area under the line PQ. From that, we need to subtract area under the curve. Or you can find the area of the trapezium also. X1, P, Q, X2. That will give area of the trapezium. So let's find out the equation of the line PQ. To find the equation of the line PQ, we need to know the coordinates of P and coordinates of Q. For P, the x coordinate value is given as 1. So this will be 1 comma. So to get the y coordinate value, substitute x equal to 1 in this equation, we will get the y coordinate value. Similarly for Q2 also, the x coordinate value is 2. To get the y coordinate value, substitute the value of x in this equation to get the y value. Okay, once you know the p and q value, coordinate value, you can calculate the equation of the line PQ. Or you can find the area of the trapezium. From that, you can subtract the area under the curve. Whichever is easy to you, you follow that method. I will find out here the equation of the line PQ. For that, I'll find first the value of P, coordinates of P. When x equal to 1, what is y? Y is equal to 1 plus 2 divided by 2 times 1 minus 1 the whole square. This is equal to 1 plus 2 divided by 2 times 1 minus 1 will be 1 square, which is 1. So 1 plus 2 will be 3. Okay. So P is 1 comma 3. Next, let's find out for Q, x is 2. So y is equal to 2 plus 2 divided by 2 times 2 minus 1 the whole square, which is equal to 2 plus 2 divided by 2 times 2 is 4. 4 minus 1 will be 3. 3 square is 9. 2 plus 2 divided by 9. So 9 times 2 will be 18. 18 plus 2 will be 20. So 20 over 9. So Q will be 2 comma 20 over 9. Okay. Now we know P and Q value. Then let's write the equation of the line PQ. Y minus y1. We will take the y1 value as 3. M times x minus x1, which is 1. Okay. First, let's find out what is the gradient. M is y2 minus y1. So 20 divided by 9 minus 3 divided by 2 minus 1. 2 minus 1 will be 1 in the denominator. So numerator 20 over 9 minus 3. So 20 minus 27. So negative 7 over 9 is the gradient. Y minus 3 equal to minus 7 over 9 times x minus 1. Make y as the subject. Y is equal to negative 7 over x. 7 over 9 times x plus 7 over 9 plus 3. So y is equal to negative 7 over 9 x plus 27 plus 7. 34 divided by 9. So area of the shaded region is the limit is from 1 to 2. So straight line, the equation of the line minus the equation of the curve. So area under the line minus 7 over 9x plus 34 over 9. From this subtract the area under the curve. So minus x minus 2 times 2x minus 1 the whole power negative 2. So I'll write 2 over 2x minus 1 the whole square as negative 2 times 2x minus 1 the whole power negative 2. Let's integrate this one. We get negative 7 over 9 x square divided by 2 plus 34 over 9 x minus x square by 2 minus 2 times 2x minus 1 the whole power negative 1 divided by negative 1 times the coefficient of x, which is 2. The limit is from 1 to 2. First substitute 2 for x. So negative 7 over 9 2 square divided by 2 plus 34 over 9 multiplied by 2 minus 2 square divided by 2 minus multiplied by minus, it will become plus 2x minus 1 the whole power negative 1 can be written as 1 over 2x minus 1. Okay, so 2 times 2 minus 1. Now substitute the lower limit. Negative 7 over 9 will become positive and 1 square divided by 2 minus 34 over 9 times 1 plus 1 square over 2 minus 1 over 2 times 1 minus 1. Let's simplify this one. We get negative 7 times 2 square divided by 2. So this will get cancelled. So negative 14 over 9 plus 68 over 9 minus 2, and this will be 1 over 3 plus 7 over 18 minus 34 over 9 plus 1 over 2 minus 1. Let's combine the whole numbers. Negative 2 minus negative 1 will become negative 3. Then plus 1 over 3 plus 7 over 18 plus 1 over 2. Now combine all the three numbers which has the denominator as 9. 68 minus 14 minus 34. So 68 minus 48, which will give 20 over 9. Okay. On simplification, this gives 8 over 18, which is equal to 4 over 9. So area equal to 4 over 9. The next question is, a curve is such that dy by dx equal to 3 times 4x plus 5, the whole power 1 over 2. It is given that the point 1, 9 and 5, a lie on the curve. Find the value of a. Dy by dx is given. Let's find out the equation of the curve by integrating this dy by dx. So y is equal to integral 3 times 4x plus 5, the whole power 1 over 2 dx, which is equal to 3 multiplied by 4x plus 5, the whole power 1 over 2 plus 1 will give 3 over 2 divided by 3 over 2 multiplied by the coefficient of x, which is 4, plus the constant c. First, let's substitute the point 1, 9 to find the value of c. Y is 9. 9 is equal to 3 gets cancelled, and this is 2. So 1 over 2 multiplied by 4 times 1 plus 5, the whole power 3 over 2 plus c. C is equal to 9 minus 1 over 2 multiplied by 4 times 1 is 4 plus 5 is 9. 9 power 3 over 2 will be 27. Okay. So 18 minus 27, which is negative 9 over 2. So the equation of the curve is y is equal to 1 over 2 times 4x plus 5, the whole power 3 over 2 minus 9 over 2. This is the equation of the curve. One more point is also given, 5, a, and which lie on the curve. 5, a. Substitute that in the given in the equation of the curve. So y is a, 1 over 2 multiplied by 4 times 5 plus 5. 4 times 5 is 20. 20 plus 5 is 25. So we get a 5 cube, which is 125 minus 9 over 2, which is 116 divided by 2, 58. So a value is 58. The next question is, the diagram shows the curve with the equation y is equal to 2 times x power negative 2 over 3 minus 3x power negative 1 over 2, okay, negative 1 over 3 plus 1 for x greater than 0. The curve crosses the x-axis at the point A and B and has a minimum point M. Find the exact coordinates of M. M is given as a minimum point, so in that point the dy by dx, the gradient is 0. So let's find out what is dy by dx is. Two times minus 2 over 3 multiplied by x power negative 5 over 3 minus 3 times negative 1 over 3 multiplied by x power negative 1 over 3 minus 1 will give negative 4 over 3. And this is equal to 0. So we can write this as negative 4 over 3 multiplied by x power negative 5 over 3. We can write that as 1 over x power 5 over 3 equal to, bring this term to the another side, we get 3 times 3 will get cancelled and minus into minus will become plus. So when it goes to other side it will become minus, and x power negative 4 over 3 can be written as x power 4 over 3. So this can be written as 4 over 3 equal to x power 5 over 3 divided by x power 4 over 3. X power 5 over 3 multiplied by x power negative 4 over 3 will give x power 1 over 3 equal to 4 over 3. Let's raise the power by 3 on both the sides. So we get x equal to 4 over 3 the whole power 3. So x will be 64 divided by 27. Okay. So this is the x coordinate value for the point M, and we need to find the y coordinate value by substituting the x value in this equation. So y is equal to, when x equal to 64 over 27, y is equal to 2 times 64 divided by 27 power negative 2 over 3 minus 3 times 64 over 27 power negative 1 over 3 plus 1. Y is equal to 4 over 3 the whole power negative 2 minus 3 times 4 over 3 the whole power negative 1 plus 1. So y is equal to 2 times 9 over 16 minus 3 times 3 over 4 plus 1. 18 over 16, or we can write 9 over 8 minus 9 over 4 plus 1. 9 minus 18 plus 8 divided by 8, which is equal to 1 over 8, negative 1 over 8. So m is 64 over 27 comma negative 1 over 8. The next part of the question is, find the area of the region bounded by the curve and the line segment AB. So we need to find the area of the region bounded by the curve and the line segment AB. So for that, first we need to find out the limits. The limit is x coordinate of A and x coordinate of B. Okay. So it intersects with the curve intersects with the x axis. So the y value will be 0. So by using that, from the given curve equation, let's find out the x coordinate value of A and B. Two times x power minus 2 over 3 minus 3 times x power negative 1 over 3 plus 1 equal to 0. Okay. So let's solve this equation now by taking x power 1 over 3 as t. So this will become 2t square minus 3t plus 1 equal to 0. Let's factorize this one. So 2t minus 1 equal to 0. That means t will be 1 over 2 or 1. That is x power negative 1 over 3 equal to 1 over 2, or x power negative 1 over 3 equal to 1. Let's write this as x power 1 over x power 1 over 3 equal to 1 over 2. That is 2 is equal to x power 1 over 3. Okay. To find the x value, raise the power on both the side by 3. So we get x as 2 cube, which is 8. And here 1 over x power 1 over 3 equal to 1, or x power 1 over 3 equal to 1. So x will be 1 cube, which is 1. Okay. So the curve intersects the x-axis at 1 and 8. So the limit will be 1 to 8. The y-axis y value is 0. So the x coordinate value of A will be 1 and B will be 8. Okay. Find the area of the region bounded by the curve and the line segment AB. The line segment AB has a equation y is equal to 0. Okay. So we will ignore that part, y is equal to 0. So no need to subtract. So let's integrate only the curve equation. 2x power, raise the power of x by 1. So negative 2 over 3 plus 1 will give 1 over 3. Divide by 1 over 3 minus 3 times x power negative 1 over 3 plus 1 will give positive 2 over 3 divided by 2 over 3 plus x. The limit is 1 to 8. First, let's substitute the upper limit. So this will be 6 times 8 power 1 over 3 minus 9 over 2 times 8 power 2 over 3 plus 8 minus 6 times 1 power 1 over 3 plus 9 over 2 times 1 power 2 over 3 minus 1. So this gives 6 times 2, which is 12, minus 9 over 2 multiplied by 4, which gives negative 18, plus 8 minus 6 plus 9 over 2 minus 1, and this is equal to minus 5 plus 9 over 2, negative 10 plus 9 over 2, so negative 1 over 2. So the area is, we are getting it as negative 1 over 2. Area cannot be negative, so we had to write area as 0.5, or you can write 1 over 2 also.